Thank you everyone for joining this webinar. My name is Pawel Wargocki, and I will talk about one of the methods that can be considered for use and is more and more considered is to evaluate the performance of air cleaners or gas phase air cleaners, which is the method which uses a perceived air quality. I will be speaking about general principles of the how we can use the perceived air quality for that purpose, and generally what are the methods and what are the limitations of using perceived air quality. And I will give you a couple of applications examples, and then the next presenter will be speaking more about the actual use. As I speak, we are actually running experiment, which is looking at the as developing methodology for using a perceived air quality for that purpose. So that's an interesting thing to say. Is once again I want to say that the method that I will present is for the air cleaners that are used for removing gases or vapors, or the combination of air cleaners that use one of the element of the air cleaner is removal of gaseous pollutants. So this methodology cannot be used for the particular contaminant or the biological contaminant because there is no effect on perception. Just to remind you, everyone, that indoor air is composed of hundreds of volatile, or actually thousands of volatile organic compounds. And there are different lists that list more than 300, 500, or even 1,000 chemical compounds. So the question of how do we quantify the effect of air cleaner in removal of those pollutants remains still open, because the process is not that simple. And of course, we can use the chemical measurements for that, and the chemical analytical chemistry has developed in the last 5, 10, or even 15 years, in which we have a much more sophisticated instrumentation, which of course requires a very sophisticated staff and technicians to operate them, and also researchers to evaluate the results afterwards. But nevertheless, we are capable now to measure many of those pollutants, even in the real time. And the instrument that is shown to the right, to the left, we have classical gas chromatography system, and then to the right, we have a proton transfer reaction mass spectrometry, or similar units to using the similar principle, which allow actually continuous real-time measurement of pollutants in the air. However, one important limitation of all those measurements, even though we are able to measure all of them, that we don't have models that would allow us to to predict how the change in the composition of the air, which means the removal of certain types of pollutant, will affect how we perceive the air quality. So we don't have very good models to do this. Basically, we can say those pollutants are not present, but what would be the effect on the air as it is perceived by humans cannot be predicted very well. Therefore, one of the additional methods that could be supplementary to the method of using chemical evaluations, because the chemical evaluation can always tell us what pollutants are removed, and that information is useful, is just as a supplementary, not just to replace, is simply using a man as a meter. We have organs, we have olfactory sense, and the common chemical sense that allow us to assess whether the air quality is good or is poor. And the air quality, or perceived air quality, is defined as the quality as rated by humans in subjective evaluations, and the quality is the extent to which requirements are met. And for those who are new and have not heard about the sensory evaluations of air quality, they have been used for more than 25 years routinely in the assessments of the air quality for other different purposes. There is an ICIEE report that summarizes many of those different methods. I think that it can be found and freely downloaded on internet. Perceived air quality has been used to define ventilation rates in the standards. The ASHRAE standard and a SEN standard actually define ventilation based on the sensory perception. There are standards that actually use the sensory methods for evaluation of emissions of materials, and there are labeling schemes that use that. So we should not be afraid of using it and going back and use this methodology. It has certain limitations, but all the methodologies have limitations, and chemical analysis also has a lot of limitations. And just to remind you that sensory evaluations are used in many different other disciplines. So it is not something special that we are developing here. Basically, in many of the other disciplines, the sensory evaluations of humans or senses or our perceptions are basically primed towards the other methods of analysis, or at least complementary to those analyses. So how we do measurements of perceived air quality? I mean, perceived air quality can be defined based on the different so-called metrics and or so we can assess different qualities here. We can assess odor intensity. We can assess whether the air is fresh or stuffy. But we can also assess whether the air causes dissatisfaction or is acceptable or not acceptable. So basically what we can do is we can define or assess the intensity of the perception, and we can also assess the hedonic quality of that, and both combined we can assess basically through the acceptability. And acceptability is the most commonly used metric for perceived air quality, and basically it's defined according to ASHRAE 62.1 as the air in which there are no known contaminants at harmful concentrations as determined by cognizant authorities, and with which a substantial majority of the people exposed do not express dissatisfaction. That's the general definition of acceptability. How you measure it, I will show you in a moment. You can use different sensory panels. You can use a panel that is untrained, which we call it untrained panel, and then panels that are specially trained to perform sensory evaluations. And because of the time, I will not have time to talk about trained panel. And trained panel are not often used, but they are actually recommended in some of the standards that I mentioned, and also labeling schemes they are actually used. But in our case, we will be I will be showing the method using untrained panel. The most important thing is that we all those assessments are based on immediate response or the first impression. I will show why in a moment, and it should be an impartial, so people who should not know what actually they are assessing. So the untrained panel, as defined by standard 62.1 as ASHRAE ventilation standard, is a panel of at least 20 untrained observers who render a judgment of acceptability. So basically, these are people who are not especially trained to perform, but are selected not to have sensory deficits. And sensory deficits or any health problems that would not allow them to perform the measurement. Sensory deficit can be also hearing impairment, because all those senses are connected in our brain. So this is an important thing to consider. Also, if people who are unusually sensitive to the air quality, such as people who have a certain chemical sensitivity or allergy, should not be used, or the people who actually lost the sense of smell due to injury or something like that. But 20 is the as defined by the ASHRAE standard 62.1, but actually panel size can be determined by defining the standard error that we are interested in. It's basically the standard error will define which resolution of the panel that we want to achieve. And depending on this resolution, we can define the size of the panel. Usually, we are in the neighborhood of about 40 subjects. And 40 subjects, as you can see, about 40 subjects, the differences will be very small, and then that will be only determined by the standard deviation. The standard deviation of the panel would be lying around about 0.4, 0.3, all depends on how you select your panel members. Then if we continue, I hope I can continue, because now suddenly, yeah, so if we continue, so the scale of how to measure acceptability, we use the continuous acceptability scale. And the context here is extremely important. We have to always ask in which context the assessment are obtained. It is not the context of that you are in holidays or in a pub or in a good restaurant. It's basically the context of the working or studying or learning experience. And then you assess the acceptability or any other context that is relevant to the assessment. and then but that's most common. And then basically the continuous acceptability scale shown as this is used. Acceptability, of course, can be used as a metric, but usually the metric that we use is the percentage of dissatisfied. So basically the votes of acceptability can be converted using the conversion curve that is shown here to the percentage of dissatisfied, and this is the metric how it is defined in the standard as a number of dissatisfied, or percentage of dissatisfied with the air quality. Often the acceptability assessments are actually accompanied with the measurements of odor intensity, and odor intensity will tell you how strong the odor is. And the reason for that are several reasons. I don't have much time to go into details why, but one of this is historical reason, because that was one of the first scale that was used for determining ventilation requirements as we see them today. Basically here we do not talk about hedonic character, but of it's just a perception of whether it's warm or cold if we compare to the thermal scale. So it is whether it's the strength of the odor slight or moderate or very strong. And then, of course, acceptability tells you whether this odor is at the acceptable level. So it's a very important and useful complementary measurement. And then basically from this, you can also determine a percentage of dissatisfied because some conversion curves have been developed for that as well. Sensory assessments, of course, have certain limitations, and you need to be careful of the problems that are related, like with all the other measurements. The two major problems is the effect of temperature and relative humidity and adaptation. Basically, one problem is that together with our olfactory and chemical sense, we have a thermal sense that is located in our an olfactory region. And basically, it's sensitive to the temperature and humidity or the enthalpy of air. And with the increasing enthalpy of air or increasing temperature and relative humidity, the assessment of the air quality will change independently of the pollution level. So we will be assessing the air as less acceptable if the temperature and relative humidity is increasing. That requires adjustments, and the models for these adjustments and corrections have been developed. The other problem is that our olfactory sense is not a very well developed sense, in a sense that we get very quickly fatigued. Our sense gets very quickly fatigued, and we get adapted to the air. And this is just an example of how quickly adaptation takes place. And you can see that this is how acceptability change with the number of inhalations of the same air you take. So after one inhalation, you have a change, you have air quality, and then already after 2 or 4 and 6 inhalations, you can see that there is improvement of air quality, but that's basically caused by the sensory fatigue. It doesn't mean that the air quality is improving, which means that basically the first evaluation is the most important. And this is the best illustrated by this study, which showed that how the visitors to the space assess the air quality and how the occupants. So basically, depending on the ventilation rate. So basically, if you stay in the room for long, basically you will not be able to distinguish the difference, but the difference there is, if only you take the first impression. Then there is a methodological aspect, is whether people should enter the spaces and make the evaluation of air quality, or whether we can extract the air from the space where we want to assess the air quality, and basically use diffusers or special methods of presenting the air under evaluation to people. That is still, principally, there should be no difference. There are studies that show some difference, but we are working on some developments of some relations. To me, the difference, if it is appearing, is caused by either the the background level of air quality. So if you have a large contrasts in your assessment, then you will have a different assessment, or there could be also on the number of inhalations, that also the sensory fatigue. So just to complete, I give you 2 examples, and Van Leer, who will be speaking just after me, he will show you the actual application of this. So Bjarne has already shown you this graph, and actually I will not spend much time of saying it, but basically using the sensory perception or sensory evaluations, we can develop the so-called dose-response relationships, showing how the air quality is changing with the changes in ventilation rate, and that can be done with and without air cleaner in the space. And the differences at the certain level of air quality, here we are talking about 20% dissatisfied, can be these changes can be attributed to basically the effect of air cleaner, and this effect can be expressed as cleaner delivery rate or the ventilation rate that can be credited basically by the use of the air cleaner. And then what we can do is basically, if we have the principle of estimating the ventilation requirement, and depending on where the effect is seen, is the effect seen for the people part of the building part, all of this together, then we can credit the contribution of the ventilation when using the air cleaner. And the other example also Bjarne mentioned is that a chemical analysis may provide you information with the byproducts, but will often not tell you about the effects of those byproducts if they are produced by the air cleaner on our perception. So basically, sensory evaluations have additional importance, not only that they capture the entire perception of the air, but also they tell you whether there could be potentially harmful pollutants that will degrade the air quality that are produced during the air cleaning process. So I'll stop here. Thank you very much for your attention.